This screencast is on density. It's an important and useful physical property. Density compares how massive an object is with how much space it takes up. I have several different substances here. This is mercury. It has a very high density. There's a lot of mass in a unit of volume. Notice the units here. It is going to be grams, which is our unit of measure for mass, and then divided by centimeters cubed, or that could also be milliliters, because a centimeters cubed is the same thing as a milliliter. We compare that here to, I think this is platinum, 21.5, even more dense than mercury, but platinum's a solid and mercury's a liquid. Aluminum, we have had experience with that. It's a very light material for the amount of space it takes up, so it has a very low density, 2.7 grams per centimeter cubed. When working with density, we might have to calculate the density, or we can use the density to calculate the mass of something if we know the volume, or if we know the mass, we can calculate the volume if we know the density. And density of pure substances is something that you could look up. So it has units of grams per centimeter cubed, or as I mentioned before, grams per milliliter. Both of those are appropriate, and it's good to keep in mind what units you're expecting for density. It helps to make sure that you get the problems and calculations correct every single time. Rearrange the equation before plugging in the measurements. This just makes it a whole lot easier. It is an easy way to go about solving a problem. Because once you get the equation rearranged, and we'll just use D equals M over V, just to kind of shorten this up a little bit, then it's just plug and chug once you've solved for the variable you're looking for. An easy way of doing that, now you can always do it algebraically, but you can also use a triangle trick. And the way you work with a triangle, you got to make sure it's drawn correctly, and you want to check it with a known equation like what we have right here. So you cover up the one you're looking for. If I'm looking for density, I would cover that up. If the variables are on top of each other, as in this case, it's division. If I'm solving for mass, I would cover up M, and if they're beside each other, it's multiplication. So it becomes a very, very easy way to rearrange the equation. Always include units in the math problem and in the answer. These measurements have meaning and purpose, and we need to include those units so that everything makes sense. So here I have a problem. Now, I was a little tricky with this problem. A piece of copper has a mass of 57.54 grams, and then I give you the dimensions, and I ask you to calculate the density. In order to calculate the density, you need mass divided by volume. But in this case, I did not give you volume. It is something that you could calculate. Now, if it is a regularly shaped object, you know how to calculate the volume. It is length times width times height. So you're going to have to do that calculation first, and this becomes a two-step problem just to make this a little bit higher level type of calculation since you are upperclassmen. I also hid a little trick in here, and if you read through the problem, you will notice that right here is my trick. All the other dimensions I gave in centimeters, but when I talk about the thickness, I gave you that in millimeters. You would need to convert these millimeters to centimeters before calculating the volume in order to get the problem correct. Now, I will often do things like this because I know you're not used to dealing with units, and I want to make sure that you pay attention to those. So always look at the units. They have to jive if you're going to multiply them together. So we'll need to convert this, and I'll show you the strategy for it. First thing, you want to get the dimensions in common units. So we'll convert those millimeters to centimeters, so we just have to move the decimal over one place. Then we want to calculate the volume in cubic centimeters. So length times width times height, again, all in the same units. And we want to deal with sig figs as well. This has 3 sig figs. This has 3 sig figs. This has 2 sig figs because leading zeros are not significant, and when you multiply things together, you have to go with the least number of sig figs. So my answer can only have 2 sig figs, so it's 6.4 centimeters cubed. Now I have my volume. Now I can actually get to answering the question. So density is mass over volume. The mass they gave me in the problem is here, and then the volume I just calculated is here. This mass has 4 sig figs, the volume has 2 sig figs, so when I divide, my answer can only have 2 sig figs, and you have to round correctly for this one. So it is 9.0 grams per centimeter cubed, because these units don't cancel out, so you leave them just the way that they are. Density is an intensive property of matter. It does not depend on the quantity of the matter. If I take this brick and I cut it in half, it would have exactly the same density, because while I've halved the mass, I've also halved the volume, so our density remains constant. Here's a difference on a molecular level of what we're talking about with density. In a brick, the particles are really, really close together, and so we've got a lot of mass per unit volume. In styrofoam, even though they're the same volume here, you can see the bricks are about the same size, we don't have as many particles. There are air pockets in the styrofoam, so it has less mass per unit volume, and when you would feel them of equal size, the styrofoam would feel lighter, but we would describe that as less dense. Let's see. Extensive properties, as you learned earlier in the semester, depend on the quantity of matter. So that would be like mass and volume independently, not density. Here's a problem. In this case, we're not solving for density. We're going to use density to solve for the mass of mercury. Again, mercury has that nice large density for a liquid especially. So in this case, we're going to use our triangle to rearrange the equation. I'm going to cover up mass, because that's what I'm solving for, and I can see that mass is equal to density times volume. First thing I want to do is I notice that there is a difference in units. My density is in grams per centimeters cubed, and my volume is in 95 milliliters. Milliliter is equal to a centimeter cubed, and I want to get my units so that they jive in working a problem. So just go ahead and convert that. Mass is equal to density times volume, and now that I have my equation rearranged, it becomes very, very easy. I'm going to plug in my numbers, density times volume, and you'll notice that your centimeters cubed cancel out. That leaves us with only grams as our units, and that makes sense for mass, because grams are a measurement of mass, while milliliters and centimeters cubes are measurements of volume. When you plug those into your calculator, this is what it spits out, but we have to deal with sig figs after that. We're multiplying, so we go with the least number of sig figs. I have 3 here, and I have 2 here. So I multiply those two together. I need 2 sig figs in my answer. So I'm going to start at the beginning of the number and go over 2 sig figs. So 1 and 2. Then I consult the next number to see if it's going to make this 2 round up. And if it's 5 and above, it will. So my answer for this one, the one I'm going to report, is 1,300 grams. It has 2 sig figs, no decimal point at the end, because that would make it 4. Now that we know how to get the volume of a particular substance, a regularly shaped object, let's figure out how to find the volume of an irregularly shaped object. Those can be very hard if you're trying to measure it with just a ruler. So an easy way to find the volume of a irregularly shaped object is by volume displacement. So a solid displaces a matching volume of water when the solid is placed in the water. So what you would do is you would take a graduated cylinder and you would read it to its exact volume. Then you would take the object and carefully place it into the graduated cylinder, making sure you don't splash out any liquid or water. So here is the object. It's going to go into the graduated cylinder, and the volume of the water goes up because it has been displaced by the object. And now the graduated cylinder reads at 33 milliliters. So I can see that my volume of the object is just the difference between these two. So I have 8 milliliters or 8 centimeters cubed. Now again, the difference between these two, milliliters we generally reserve for liquids, and centimeters cubed we generally reserve for solids. Here's another density type problem. So we've got our mass of a metal, and we place that metal into the graduated cylinder just like we saw, and the same levels there. So we've already calculated our volume from that. And so then we're just going to take our mass, which is 48 grams, and we're going to divide it by our 8 milliliters, and we end up with 6 grams per centimeter cubed, or grams per milliliter. So this would be your correct answer here. Water has a density of 1 gram per milliliter, and that's going to be something you're going to need to remember as we go through the semester, because I'll make you recall that often. If something is more dense than water, it will sink in water. If something is less dense than water, or has a density less than 1 gram per milliliter, then it will float. This goes for all substances, but most of the time when we're putting stuff in another liquid, we're talking about water. Those with greater density sink, those with less density float. So if we look at some of these, we can see a cork is going to float. Ice floats, and the reason ice floats, even though it is made of water, is that when it freezes, ice actually creates these kind of spaces in between the particles, and because it becomes less dense. And we'll take a closer look at that as we go through the semester. Sugar is quite dense, and so things that have sugar in them is going to be more dense than water, and those will sink. And you'll see lead here. It has a very high density, and this would we used to use lead weights if you go fishing, so that you can get the fishing hook to sink to the bottom of the water, so that you can, or sink lower in the water, so that you can catch maybe catfish or flounder or something like that. More and more they are asking that you not use lead weights, because lead is a toxin that the fish do pick up. Gasoline is going to float, so if there's a gas spill in the ocean, that gasoline does float. A lot of times what they'll do is contain it with something else that's floating, and then to get rid of it, they'll set it on fire. Seawater is more dense than regular water, and the more salt something has, the more dense it becomes. And here's that mercury. You can see mercury as a liquid has a higher density than lead. Now, density is temperature specific, so you'll see here they're telling you what temperature we measured the density at. When things, when we increase the temperature, the particles tend to move a little further apart, and it will change that density. So, if we look at the densities of Karo syrup, vegetable oil, and water, think about which way it is going to end up if you were to mix them all in a graduated cylinder based on density. The correct answer is going to be number 1. You have vegetable oil, which has the smallest density, that would float to the top. Water, it would be the one in the middle, and then the Karo syrup has a density greater than water, so it would sink to the bottom.